Welcome to part 1 of 2 of the Precision Sustainable Agriculture video about the Gateway and Node Wireless Data Logging System. In this video, we'll cover a brief history and explanation behind the system, how the data flow works, an introduction into the hardware that comprises the system, and the advantages provided by the system. The Gateway and Node Data Logging System was designed specifically for this project in a collaboration between the USDA Agricultural Research Service, Acclima Inc., North Carolina State University, and the University of Maryland. It is a low-cost alternative to off-the-shelf data logging systems and uses open source code to make it adaptable to the evolving needs of the project. Why did we want a wireless solution? To give us near real-time access to sensor data collected on farm, and to monitor the system so as to reduce response time when problems arise. Wireless also reduces damage to the soil and plants surrounding the research plots. Transmitting data to the cloud automates data storage and backup and allows us to integrate the incoming data into end-user interfaces for visual display and decision support tools. Why a gateway and node radio network structure? The gateway serves as a central data collection point. Data from multiple nodes are sent to the gateway located on the edge of the field. In cases where cellular service is limited, this facilitates manual retrieval of data. This structure also helps reduce overall costs since only one cellular subscription is required per gateway instead of per node. Less cost means we can outfit more sites and collect more data. So what does the data flow look like? First, you have a node in each experimental treatment, in our case, cover cropped and bare plots. These nodes collect data from the sensors and transfer it to the gateway using long-range radios. The gateway receives and saves the data from the nodes. At user-defined intervals, the gateway transmits data via cellular connection to the cloud server where it is stored. Our project has a local server that pings the cloud server at regular intervals for any new data. The data is downloaded to the local server, then is pushed to a database where it can be accessed by the research team and by growers via a password-protected user interface. Let's take a look at the hardware that makes up the system. We'll start with the gateway. The gateway can be distinguished by the two antennas at the top of the enclosure. On the door of the enclosure is the solar panel that charges the battery. Inside the enclosure, you'll find the gateway circuit board. Other details are the serial number on the bottom right-hand corner of the label that is used to identify the gateway and link it to a site. The last two digits of the serial number is the default radio address for the gateway. There's a snap connector between the solar panel and the circuit board that can be disconnected to completely remove power from the gateway if a full reset is needed. The connector is needed because the off-on switch on the circuit board does not stop the solar panel from powering the board. Here's a closer look at the gateway. The SIM card links the cellular module to the internet. The microSD card is where all the data received by the gateway is saved and where it can be removed to directly extract the raw data files. The indicator LED indicates the status of the gateway. It is on when the gateway is in synchronization mode, when pinging the nodes for data, and when sending data to the cloud. The micro USB connection allows for direct communication with the gateway via a PC and software user menu. The onboard lithium battery provides power to keep the gateway running for days without recharging. A slide switch controls the power from the battery to the microcontroller. As noted earlier, however, it does not disconnect the solar panel. The LED under the battery clip is on if the battery is charging from either the solar panel or from an external power source. In addition to the gateway, you'll have two nodes and some sensors in your box. Nodes designated for the cover crop treatment connect to 6 sensors. 4 measure soil water content, 1 is a combined relative humidity and temperature sensor, and the last sensor is for measuring temperature below one of the cover crop residue bags for the decomposition study. The node for the bare treatment is only connected to 3 soil water sensors. The nodes look very similar to the gateway. but only have one antenna. The nodes also have a solar panel on the enclosure door. The inside looks similar to the gateway with the serial number on the label and solar panel connector in the same place. The node has some of the same components as the gateway: an external power connection, lithium battery, micro USB connection, and status LED. The node has connectors for the sensors that are not on the gateway because of the communication protocol the sensors use, as we'll describe later. Each sensor does not have to be directly connected to the node board. There is also a power switch and a charging indicator LED. As indicated, each sensor does not have to be connected directly to the node. How can that be? All of the sensors communicate using SDI-12 protocol. With this protocol, each sensor is given a unique address that functions like a phone number. Each sensor can be queried individually without causing confusion about where the information came from. This means that the sensors can be connected to a single cable going to the node as shown in the figure. Now we'll describe the three types of sensors, starting with the soil water sensor. The 3TDR310H model sensors are used to measure soil water content at 3 depths. The cylindrical form factor allows it to be glued to a 1-inch PVC pipe to make it easier to install and remove. A fourth soil water sensor is used in the cover crop treatment that is installed horizontally 4 centimeters below the soil surface, right below the residue bag. These sensors use true time domain reflectometry for the volumetric water content measurement, which means they are highly accurate without site-specific calibration. The temperature and combination humidity temperature sensors are similar. The temperature sensor is protected by thick insulation and the circuit board is protected by a thin acrylic coating. Its flat design makes it easy to place under a residue bag. The combination humidity temperature sensor comes enclosed in a vented PVC tube that protects it from water and insects. The Gateway Node Wireless Data Logging System allows us to collect diverse and continuous data over the growing season. This data set will be used to develop new models and verify existing ones to help better understand water, nutrient, and climate dynamics in cover crop systems. The automated data flow in the cloud provides quick access to data for both researchers and growers and facilitates integration of the data into end-user interfaces and decision support tools. Thank you for watching part 1 of the 2-part series on the Gateway and Node Wireless Data Logging System. Be sure to watch the Part 2 Getting Started video to learn how to begin using the Gateway and Nodes.